In this video, we'll be taking a look at SSR output configuration on the PM-50 Graphical Panel Meter. In a previous video, we discussed PM-50 setpoint alarms. Each setpoint alarm has a corresponding solid-state relay output which closes by default while the alarm is active. For example, setpoint 1 controls output 1 and setpoint 2 controls output 2. This allows the PM-50 to control DC-powered devices up to 30 volts based on user-configured setpoint statuses. There are two of these setpoint output pairs built in. If you require more than two, you can add a dual or quad relay module to your unit for a total of up to 6 setpoint output pairs. In this video, I'll be configuring a 24-volt LED bulb to turn on when a setpoint alarm is active. Before we get started with configuration, we'll take a quick look at how the solid-state relays are wired. The example images here show two options for wiring an LED to SSR output 1. You can see that it's possible to wire the relays using either syncing logic as shown on the left or sourcing logic as shown on the right, and you'll want to note that the terminals being used will differ based on which wiring option you choose. For this demonstration, I'll be wiring an LED to SSR output 1 using syncing logic as shown on the left. Here's an image showing the physical wiring of my unit. You can see that the LED is wired between the output 1 terminal and 24 volts. You can also see that we have 0 volts wired to the output common terminal. With this LED now wired to the PM-50 using syncing logic, we're ready to take a look at the configuration and demonstrate it in real time. I've already logged into my unit using admin credentials, so I'll click once on Device to get started. Next, click once on Setpoint Configuration. For this demonstration, my PM-50 already has a non-latching absolute high alarm configured to turn on when the input detects a simulated flow value of 300 GPM or higher. I'll now click once on the Setpoint Configuration menu item to show this alarm configuration. As you can see, setpoint 1 is selected and it's an absolute high setpoint with unbalanced hysteresis. And here we can see the setpoint value is 300 and the hysteresis value is 50, meaning that if our alarm is triggered at 300 GPM, it will stay active until the flow drops to 250 GPM. Further down, we can also see that the reset action is set to auto, and our output logic is set to normal. If output logic were set to reverse, the setpoint alarm and SSR would be on when the alarm conditions were not met. Be sure to save at this point before moving on to the next step if you've made any changes. Next, I'll click once on the Setpoint SSR logic menu to expand it. For this example, the LED has been wired to the PM-50 using syncing logic, so I just need to make sure that sync is selected here to match how the output is wired, and we can see that it is. If you're using both of the built-in outputs, remember that they must be wired the same way. You cannot have one syncing output and one sourcing. Once again, remember to save if you've made any changes. At this point, we're ready to navigate to the home page and test out the newly wired and configured SSR output. For this demonstration, I'll be displaying both the web server and a webcam pointed at my PM-50 unit. I'll start increasing the simulated flow value, and we should see the setpoint 1 alarm annunciator banner appear when the flow hits 300 GPM. At that same time, we should see the blue LED wired to SSR output 1 turn on. And as you can see, the blue LED wired to SSR output 1 turned on with the setpoint 1 alarm. I'll now decrease the flow back below the setpoint value minus hysteresis, which should make the annunciator banner disappear and the blue LED turn off. With our previously configured hysteresis value of 50, this means that the flow must drop to 250 GPM to deactivate the alarm. As you can see, the LED turned back off as expected once the setpoint alarm was no longer active. If I increase the flow back to 300 GPM, you'll see the setpoint alarm trigger again and the LED turn back on. And that's it for PM-50 solid-state relay outputs. Thank you for watching.